Hello. In this session, we're going to talk about the ALC hardware. And let's start by just looking at an overview of our system architecture. We have a web control server right here, and this is where the actual web control application runs. It's installed in a single place and served up as web pages to clients. So this light blue line is symbolizes an IP network. We have the server sitting on the network, and then we have one or more clients accessing that server with nothing but Internet Explorer. Okay, so you can have one instance of web control installed, and then many, many clients only with Internet Explorer that browse to the server just like you would any other web page, and you would pull up web control. Now, of course, we also have the ability to have wireless devices or WAP devices. So for instance, we have PDAs and we have telephones that are serving WAP, and they can access the server themselves. They can be anywhere. They don't have to be physically connected to the network. The whole point is that they're wireless. Now from this IP network, we have our router right here. This is a BACnet router, an ALC BACnet router, and it routes BACnet from Ethernet to ARCnet. And the reason it does that is all of our actual controllers that control equipment, sometimes called modules, sit on this ARCnet network. This is a high-speed, very, very efficient network. It's BACnet over ARCnet, and we route from IP through this router to BACnet over ARCnet. We see lots of different types of controllers. We have the ME line, which is multi-equipment, and that's typically seen in things like chiller plants. We have the single equipment line. You can have one control program in here, and this controls things like air handlers. Okay. Then we have our ZN controllers, and they're terminal unit applications. You'll see those on DAV boxes and fan coil units, things like that. We, of course, have our own line of sensors called RS, and we're going to talk about all of these different components and modules in a moment. But what I'd like you to get out of this slide is the fact that, hey, our architecture is we live on the IP backbone as far as the server and the web control clients are concerned. The web control clients use IE to browse to the web control server. And then as far as the actual controllers and modules go, they route their information through an LGR between the ARCnet and the Ethernet. And we have these various controllers distributed throughout the building. Let's take a look at some of these controllers. Here we have our BACnet router. I talked about that earlier. This is an LGR25, okay? And essentially what we are doing is we are routing between the Ethernet right here out of a BACnet, ARCnet over BACnet port, okay? And we'll see that is very typical. Here's our control module network. This is ARCnet 156K, and of course this would run to all of the controllers through the building. This, of course, would get us on the Ethernet backbone. This can have control programs in it as well, and it's very typical that, in fact, it would. What it does not have is points. Okay, so the primary purpose of this controller, of course, is to route between the Ethernet onto the ARCnet. Now, sometimes with the LGR, you'll see a number like a 25, and that denotes the number of third-party points that we can use inside of this controller. So this controller not only routes between Ethernet and ARCnet, but it also has the ability to translate 25 third-party points from BACnet to some other protocol. Now, this is the ME-LGR. You'll notice here that we have an expansion port. We still have the ability to route from Ethernet, or IP rather, to ARCnet, but in addition to that, we have the ability to add expander boards on here that provide point count to this controller. So with our line, you can have a router that also is a multi-equipment line. ME stands for multi-equipment. You can download more than one control program in it, and when you add the expander boards to it, it has points on it. So it's a controller and a router all in one controller, okay, all in one module. It's called the ME-LGR. It also has the ability to have third-party points. This particular one does not, but it could have the ability to translate protocols for us. Now we also have what's called an AAR. This is a small router, and what this does is this expands the capability of our ARCnet. This is an ARCnet to ARCnet router. So previously we saw controllers that routed from IP to ARCnet. This basically extends the capability of the ARCnet network by providing another route to it. So typically our ARCnet networks can have 99 control modules on it. You can extend that by putting this device on it and then having yet another 99 modules on the ARCnet. This is the MEA12U. This is a new line of controllers. This has multi-equipment capability, of course. That's hence the ME, multi-equipment. You can download one or more control programs in it, and you can see that you have inputs and outputs in it. This is also expandable, so we can have expanders on that, and we can see that right here. And we'll talk about that in a moment. Now, what's nice about this is we have our inputs right here, 12 inputs. They're universal. In other words, they can be jumped from thermistor. We can bring voltage in. We can bring milliamps in. And our outputs are also universal. We have 8 of those. So they can be jumped from 0 to 20, 0 to 10, or relay. So this is a very versatile module. You can have multiple control programs in it. The inputs and the outputs are both universal in nature, and we can have expanders attached to this particular board. And here's what one of those expanders looks like. And this is an MEX 816U. It has 16 inputs, 8 outputs. They're also universal. And what's nice is that this module's footprint is small enough so that it can actually stack right on top of this ME812U. So it'll sit right where right where you see the automated logic logo, and it will sit on top of this board and expand the point count on it. Now, in addition to that, you can have more control, or rather more expander boards linked to that ME812U or any of the ME line. And essentially you do that by daisy chaining them. So you can stack one expander on top of the ME812U, or you can simply have up to 5 expanders daisy chained and distributed up to 100 feet away throughout the system. Here's an example of a single equipment control module. This is an SE616, or rather an SE616-6. What we have here is we have 16 universal inputs, we have 6 analog outputs, and we have 6 digital outputs. Okay, this is a single equipment control module. SE stands for single equipment, ME stands for multi-equipment, and this is our point count. Again, we have 6 analog outputs, 16 universal inputs, and 6 digital outputs. And again, this of course does sit on the ArcNet. This is a new line of controllers called the room controller, and here's one with a display. We make one without a display. And this is actually a control module. It mounts to the wall, and you can see the user has an interface where they can actually configure things in the room. They can schedule the device, for instance. They have an override, and they can adjust set points. And this display brings in various data, of course, the zone temperature, your set points, outside air, etc. This is designed for a single piece of equipment. It does actually typically get mounted on the wall of the room, and it is the interface, it provides the interface that the user uses to do things like override and adjust set points. And this is called the room controller. Here's an example of one of our terminal units, the ZN341B+, and we have different configurations on them. But essentially what we have is 3 digital outputs, 4 universal inputs, and 1 analog output. Now this is designed for a VAV box. You can see right here that we have a place to actually clamp the spindle on it, and there is an actual actuator inside of this. We do have flow sensor pickups right here, and this is a typical terminal unit control module, obviously for a VAV box because you have your flow pickups and you have your actuator in it, but we have different flavors of this, just like we do of all of our control modules. So we have the ability to control terminal units that don't need an actuator, like for instance, it might be something like a fan coil unit. And like I said, this is a typical terminal unit control module. And then finally, we have our room sensors themselves. This is a picture of an RS sensor. This is an RS Sensor Pro. And what we have in here is, of course, we'll have our room temperature. We can denote whether we're occupied or unoccupied. We have the outside air. We can do Celsius or we can do Fahrenheit. And you can see the various pieces of information. This one actually happens to control a unit with a fan on it. So you can see we have fan speed. We have the ability to show our heating set points and our cooling set points. And this is a very versatile line of sensors. We have 4 flavors. This one happens to be an RS Pro F for controlling fans, but we have an a unit with a fan on it. But we do have RS Pros that are typically used in things like VAV boxes that have a nice display and the ability to override and adjust temperature. We have an RS Plus, which does not have the display on it, but it does have the set point adjust and the override, and then an RS base that basically is just a blank housing that just picks up the temperature. So we have a full range of sensor product for you as well. And that's a brief overview of our hardware.